Every month, over 2 billion women experience menstruation, yet something so natural demands an engineered solution, one that protects health, dignity, and mobility. Sanitary before industrial manufacturing, women relied on reusable cloth, often unsafe and unhygienic. Infection risk, discomfort, and social restrictions pushed engineers and scientists to rethink menstrual care through material science. Pads are not just hygiene products, they are silent enablers of daily life, education, and work. A modern sanitary pad must perform three critical functions simultaneously: rapid fluid intake, secure retention under pressure, and surface dryness. Achieving all three requires precise layering. Each at the core lies superabsorbent polymer (SAP), a material capable of absorbing up to 300 times its weight, chemically engineered to lock liquid inside it. Absorption alone isn't enough. The top layer must pull moisture inward instantly, while the core traps it permanently. This directional flow, known as capillary action, is engineered to keep the surface dry. Prevents leakage even under body pressure. With a specific engineering rollout, because these products contact sensitive skin, manufacturing must meet strict hygiene standards. Controlled air pressure, filtered airflow, and contamination free materials are, with the purpose defined and the science understood, the journey now moves to the source, raw materials. Each fiber and polymer entering this factory has been selected for performance, safety, and reliability. Essential before production even begins. In the next chapter, we follow these materials from origin to prep. The heart of a sanitary pad begins in nature. Fluff pulp, derived mainly from sustainably harvested pine trees, is chosen for its long, flexible fibers. These fibers create microscopic channels that guide fluid quickly into the pad's core. Aeration, where nature meets precision engineering. Wood chips are mechanically and chemically processed to separate fibers without damaging their structure. Fiber length is critical. Too short and narrow achieve leak-proof performance. Manufacturers rely on superabsorbent polymers. These polymers are synthesized through controlled chemical reactions, creating cross-linked structures that trap liquid at a molecular level. Desorption slows too long and uniform layering becomes impossible. Too much polymer makes the pad stiff and uncomfortable. Too little causes leakage. Engineers calculate exact ratios to ensure flexibility, comfort, and reliable absorption. Every gram matters. The top sheet, the layer touching skin, is made from non-woven polypropylene. It is engineered to feel soft while actively pulling liquid downward, reducing skin irritation. The back sheet acts as a final barrier. Thin yet impermeable, it prevents leaks while allowing minimal airflow. This balance is essential before production begins. All materials are sterilized and stored in controlled environments. Moisture, dust, or contamination at this stage could compromise millions of finished products. To prevent discomfort and overheating, and maintaining dryness with materials prepared and precision calibrated, the factory is ready to begin assembly, where speed, accuracy, and consistency collide. This factory doesn't simply assemble pads, it engineers them at high speed. Every motion is synchronized to maintain accuracy while producing thousands of units per hour. Compressed pulp boards are broken down in a defibrillation chamber. This step maximizes fiber surface area, allowing liquid to travel rapidly once inside the pad. Super absorbent polymers are dosed with milligram level precision. Sensors continuously monitor flow rate to ensure uniform absorption across every pad. Once mixed, the core is shaped and lightly compressed. This creates structural stability while preserving internal air spaces essential for rapid absorption. The top sheet is bonded using heat or ultrasonic energy, never adhesives that could irritate skin. This maintains softness while securing the layers permanently. The back sheet is laminated last, sealing the pad and preventing leaks. Micro-venting allows airflow while blocking liquid escape. Wings are engineered for stability. Their placement, and even at full speed, each pad is monitored by optical sensors. Any deviation in thickness, shape, or density is instantly rejected. Adhesive zones RC design alone is never enough. Before any pad reaches a consumer, it must survive control testing that simulates real world use, movement, pressure, and repeated flanges. Use synthetic fluid designed to match viscosity and flow rate of menstrual blood. This ensures consistent, repeatable test results. UID extract through time measures how quickly liquid passes through the surface. The faster the transfer, the drier the skin remains, reducing irritation and bacterial growth. Pad must retain liquid even under pressure from sitting or movement. Rewet testing ensures absorbed fluid does not return to the surface. Posture. Alkulated to prevent shifting during movement. Side leakage is tested by tilting the pad, mimicking natural body posture. Wing placement and core shape are evaluated here. Menstrual flow is not continuous. Pads are tested in cycles to ensure absorption remains consistent over time. Only pads that meet strict thresholds for absorption speed, retention, and leak prevention advance to packaging. Once validated, the pads move forward, ready for sealing, sterilization, and distribution. Pads are manufactured as a continuous web. Cutting them apart at high speed require rotary die cutters. Use hardened steel molds to carve each pad with millimeter accuracy. This ensures consistent fit and reliable wing placement. Whereas perfect timing, errors measured in milliseconds could compromise shape and sealing. Sealed edges prevent fiber shedding and improve comfort. Heat levels are carefully controlled to avoid damaging absorption layers. The adhesive strip anchors the pad to underwear. It must bond securely yet release cleanly, requiring precise formulation and placement. Each pad is folded to protect the absorbent core while minimizing package size, critical for transport efficiency and consumer convenience. Individual wrapping vision systems verify seal integrity and wrapper alignment in real time. Faulty packages are removed automatically. Aids a hygienic barrier, protecting the product from moisture. Individually sealed, the pads now move toward bulk packaging, where logistics efficiency meets consumer presentation and contamination until the moment of use. Once individually sealed, pads are grouped into retail quantities. This step